Hello all, welcome back. I'm here to explain you the remaining two questions of DDCO Lab Assignment, that is 7th and 8th question. So let me move on to the questions. Here's up with 7th question. Design Verilog program to implement types of demultiplexer. First of all, let me tell you what is demultiplexer. So demultiplexer, it is also abbreviated as demuxer or demux. Demultiplexer is opposite to multiplexer. In multiplexer, we used to have 4:1 or 2:1 or 8:1. Whereas in demultiplexer, it is vice versa. We'll be having 1:4 or we'll be having 1:2 or we'll be having 1:8. Okay, here it's the example of 1:4 and it's the example of 1:8. Here we'll be having only one input and we'll be having 4 outputs, or else we'll be having one input and 8 outputs. Okay, that what the sentence means. It is the hardware tool which creates 2 or more streams of data from a single stream input. From a single input, we can demultiplexer hardware tool will produce 2 or more than 2 streams of outputs or 2 or more streams of data. Okay, this is what demultiplexer means. So back to the Verilog program. So this is the Verilog code to implement demultiplexer, and this is for 1:4 demultiplexer. Okay, so demux is the name that is given. Here we'll be having one selector S and one input D and one output. Okay, input S will be having, as it is 1:4, we'll be having S0 and S1, two selectors, and one input D, and we'll be having 4 outputs, that is Y0, Y1, Y2 and Y3. So Y value varies from 0 to 3, S value varies from 0 to 1, or else we can write it as 1:0, and we can write it as 3:0. Okay, that's what it is written, 3:0, 1:0 select lines. And these are the 4 cases, K0, 1, 2, 3, and Y0, Y1, Y2, Y3 value will be equal to the input D. Okay, and let me show you the output. So this is the output, and S value it is given as 0, 0, which means that it is pointing towards Y0. What is D value? What is the input that is given? It is 1. So Y0 value will be equal to 1 and other all outputs will be equal to 0. Y1, Y2, Y3 values will be equal to 0 and Y0 value will be equal to 1. Okay, because D value is given as 1 and select line is 0, 0, which means that it is pointing towards Y0. If the select value is given as 0, 1, it will be pointing towards Y1, so that Y1 value will be 1 and other all value will be 0. If it select value is given as 1, 1, then it will be pointing towards Y3. So Y3 value will be 1 and other all value will be 0. So this is all about 7th question, demultiplexer. We came to know what is demultiplexer, and we came to know it is just dead opposite to multiplexer. We'll be having 1:2, 1:4, 1:8 demultiplexer. Okay, then we shall move on to 8th question. 8th question is to design Verilog program for implementing various types of flip-flops such as SR, JK and D flip-flop. So SR stands for set reset, JK stands for Jack Kilby flip-flop, and D stands for delay flip-flop. Let me tell you what is SR, JK and D flip-flop. So this is SR flip-flop. It is a gated set reset. As I said, it stands for set reset flip-flop, and we'll be having two inputs, S and R. Input controls the state of the flip-flop. These S and R will control the state of the flip-flop when the clock pulse goes from low to high. When the clock will go from low to high, these two inputs will control the state of the flip-flop. What is clock? Clock is a signal. It will be having either the value as 0 or 1. Okay, next we shall move on to D flip-flop. What is D flip-flop? It is a delay flip-flop. It is a digital electronic circuit, and it is used to delay the change of the state of its output signal. Output signal, it is denoted as Q. So this output signal is controlled by this D flip-flop, or it is delayed. Output signal is delayed. Until when it will be delayed? Until the next rising edge of the clock timing input signal occurs. So until the next rising edge of the clock, this output signal will be delayed with its change. Delay the change of the state. Output will not be changed. Its change will be delayed until the next rising edge of the clock timing input signal. Okay, so this is all about D flip-flop. It is just used to delay the change of the output signal until the clock timing changes, until the next rising edge of the clock. Next is JK flip-flop. As I said, it stands for Jack Kilby flip-flop. It is one of the most used flip-flop, most popular flip-flop in digital circuits, and in universal circuits, universal flip-flop, it will be having two inputs. One is J and one will be K. So it is from this we came to know all the universal flip-flops will have JK, and JK is used popularly all over. Okay, this is all about JK flip-flop. And D flip-flops truth table and characteristic table. I'll tell you SR flip-flops truth table and characteristic table. And here in the display you can see this is the circuit of SR flip-flop. Here from the half of this is SR latch circuit. Okay, here you can notice one output is taken as input for another. Okay, here it depends on the other output. Okay, so this is all about SR latch, and from SR latch we'll be creating SR flip-flop. Okay, here you can see CLK means clock. Okay, let me tell you how to write the truth table. Before going into that, let me simplify this circuit. The simplification will be having S, R, and you'll be having here two outputs. One is Q and another one is Q bar. Okay, and here you'll be having clock. I'll write it as C. Okay, or else you can write it as CLK, clock. Okay, then let me write the characteristic truth table for it. First let me write the truth table. So the inputs are clock, yes, R, set, reset, and the output is Qn plus 1. Here you can see it is NAND gate. Okay, so to write this truth table you need SR latch truth table. Okay, here I'll be writing SR latch truth table. So here you can see, so this is the truth table for SR latch. When it is 0, 0, Q and Q bar are the two outputs. So Q and Q bar will be invalid. When both the inputs are 0, then Q and Q bar value will be invalid. I means invalid. Okay, then if S value is 0 and R value is 1, then the Q value will be 1 and Q bar value will be 0. Then if S and R values are 1, 0, then Q and Q bar value will be 0, 1. If it is 1, 1, then it will be previous output. Or you can write it as Qn and Qn bar. Okay. So truth table for SR flip-flop is when clock value is 0. Here you can notice that when clock value is 0 and when clock value is 0, if one of the input is 0 for NAND gate, then the output will be 1 for NAND gate. Hope you know this truth table of NAND gate. If one of the input in NAND gate is 0, then the output will be 1. So irrespective of the inputs of S and R, only with this clock input will be getting, with this clock input as 0, we'll be getting S star and R star as 1. Okay, so from SR latch, if one of the input is 1, from NAND gate, SR latch NAND gate, if one of the input is 1, then we can have either 1 or 0, and here also we can have either 1 or 0. So the output S star and R star is dependent only on clock, not on S and R. So, and here also Q and Q bar value is dependent only on clock, not on S and R. So S and R values are don't care. Okay. So when clock value is 0, S and R value is don't care, then we'll be getting what? The previous output, right? Then we shall move on to the next combination. When clock value is 1, from SR latch, we can note that we will be having two possibilities. When clock value is 1, we'll be having the two possibilities of outcome. It can be either 0 or it can be 1. So we shall consider S and R. We shall give input to S as 0, and for R also we shall give it as 0. Then value is 1 and S value is 0. From the truth table of NAND gate SR latch, we can note that we'll be getting the output as, when it is 0, 1, we'll be getting the output as 1, and when it is 0, 1, we'll be getting the output as 1. So when SR both the values are 0, 0, then also if in SR latch, if one of the input is 1, then we'll be having the possibilities of getting either 0 or 1, right? So we'll be getting the previous output. Then when clock value is 1 and S value is 0 and R value is 1, likewise when clock value is 1, S value 0 and R value 1. So when S value 0, clock value 1, S star will be 1. Whereas when both the inputs are 1, then we'll be getting the output as, from NAND truth table, we'll be getting the output as 0. From SR latch, we can note that when one of the input is 0, then we'll be getting the output as 1. Right? So this output will be, Q bar output will be taken as input for this. So here it will be 1. 1, 1 means we'll be getting the output as we'll be getting the output as 0, right? From NAND gate, 1 1 input means we'll be getting the value as 0. So here Qn plus 1 will be equal to 0. Then when clock value is 1 and S value is 1 and R value is 0, we'll be getting the opposite of that is 1. When all the three inputs are 1, 1, 1, that means S value 1, R value 1, clock value is 1. 1, 1 means S star value will be equal to 0. S star value will be equal to 0, and here also 1 1 means R star value will be equal to 0. We can notice that when one of the input is 1, one of the input is 0, then the output will be 1. When one of the input is 0, then the output will be equal to 1 in NAND gate. So here also it will be equal to 1, here also it will be equal to 1, but Q should be the complement of Q bar, or Q bar should be the complement of Q. So 1 1 means it is invalid. So when all the three combinations are, all the three inputs are 1, then the output will be invalid. So this is the truth table for SR flip-flop. Truth table for SR flip-flop is when clock value is 0, irrespective of S and R, output will be the previous output. Then when clock value is 1, we'll be writing the 4 combinations for SR and we'll be getting the output. One will be previous output, one will be 0, and one will be 1, and one other will be invalid. Let me write the characteristic table. So here you can notice this is the characteristic table of SR flip-flop. When 0 0 0, it will be plus 1, output plus 1, okay, Qn plus 1, previous output plus 1. Here X indicates it is don't care. So let me write the K map for this. So here you can notice that it is, let me write the positions for your understanding. It is 0th, 1st, 2nd, 3rd, 4th, 5th, 6th and 7th, right? So at second position we are having 1. Here is the second position and 1. At third position we are having don't care, and here is the third position. At fourth position we are having 1. Hope you know the positions in K-map from the first question you have solved it. And at the 6th position we are having 1. At 7th position we are having don't care. Now we have to pair it, right? So let me pair these 4 and this corner and this corner 1. Okay, so the equation for this will be, here you can notice that Qn is changing from 0 to 1, whereas S has remained constant as 1 and 1, whereas R also changed from 1 to 0, so it will be equal to S. And this corner pairing, what here Qn value is 1, so Qn, and you can notice here S value is 0 and here S value is 1, so ignore it. Then R value is 0 and R value is 0, so it will be R bar. Okay, so the equation for SR flip-flop will be Qn plus 1 is equal to R bar Qn or Qn R bar plus S. So this is the equation for SR flip-flop. This is all about how to write truth table and characteristic table of SR flip-flop. Same procedure is carried for D and JK flip-flop. Let's move on to the Verilog code. This is the program for Verilog program for D flip-flop. D flip-flop inputs are RST, D and clock. Okay, outputs are Q and Q bar. QB means Q bar. Okay, here you can see inputs D, clock and RST. Outputs are Q and Q bar. Okay, here's the cases. At zeroth case, Q less than or equal to 0. At first case, Q less than or equal to 1. Okay, and that is all about D flip-flop program. And we have to assign Q bar to complement of Q. As I said earlier, Q should be the complement of Q bar, or Q bar should be the complement of Q. In SR latch or SR flip-flop circuit, you can notice that here we had an AND gate, and here we had Q, right? And this is R. Here you had another NAND gate. Here you had Q bar as another output, and this is R. Q bar output is given as input for this NAND gate, and Q output is given as input for another NAND gate. Okay, if the Q value is 0, Q bar value should be equal to 1. If Q value is 1, then Q bar value should be equal to 0. Okay, that what this assign QB equal to Q, complement of Q means. Then is SR flip-flop. Here the inputs are SR, clock and RST, reset. Okay, outputs are Q bar. Here you can notice Q bar are the outputs. If a reset value, if reset Q value is less than or equal to 0, if reset that condition yavaga, if Q is less than or equal to 0, else begin. These are the 4 conditions, 4 cases. Q value less than or equal to Q, Q value less than or equal to 0, Q value less than or equal to 1, and Q value less than or equal to not Bx, complement Bx. Okay, and here also we will be assigning Q bar is equal to complement of Q, or else you can assign it as Q is equal to complement of Q bar. Okay, then this is the program for JK flip-flop. Here inputs are JK, clock and reset. Outputs are Q bar. And here's the 4 cases for JK. At 0th position, 0, 1, 1, 0, 1, 1 condition. Q less than or equal to Q, Q less than or equal to 0, Q less than or equal to 1, Q less than or equal to complement of Q. Okay, and here also assign Q bar equal to complement of Q. Okay, notice the output for JK flip-flop and SR flip-flop. When J value is given as 0, K value 0, clock 0 and reset value 1, Q and Q bar will be invalid. You came to know it using characteristic table and truth table. Okay, so here's the output. When in SR flip-flop, when S value is 0, set value is 0, reset value is 0, clock value is 0, RST value is 1, then also Q and Q bar will be invalid. This don't care means invalid. Okay, then here's the output of D flip-flop. When D clock reset value is 0, 0, 1, then the output Q and Q bar will be invalid. When we'll be getting invalid means if Q value is 1 and Q bar value is also 1, then we'll be getting invalid. Or else if Q value is 0, if Q bar value is also 0, then it is invalid. Okay, we have to get the complement of Q. Q bar should be the complement of Q. If it's not, then we'll be getting invalid. Okay, so this is all about 8th question. What we have learned from the beginning is we from the first question we got to know what is K-map and how to write K-map, and from the next questions we got to know how to write Verilog program, what are Verilog program, what are the types of Verilog program, and we got to know what are gates, AND gate, NOR gate, OR gate, XOR gate, and so on. And we came to know from the last question what are flip-flops and all. From seventh question we got to know what is demultiplexer. From sixth question what is multiplexer is known to us. So DDCO, Digital Design and Computer Organization. In digital design we learned demultiplexer, flip-flops, gates, Verilog program, K-map, multiplexer, and this is all we learned from the lab assignment question. Hope you all understood my lecturing, and thanks for watching my video. Do subscribe the channel for more updates. Thank you.